Hey guys, um, welcome to the welcome to the you know, Urbit Dev Week talk. Oh yeah, I can see it's okay. Yeah. All right. Well, I'm gonna try not to look at the screen on my phone because that's gonna be very distracting. But so basically, I'm gonna talk today about how to do some Uqbar integrations with your Urbit apps. So I'll give a little overview of like where we're at on the Uqbar project, and what you can do with it, and then we'll just dive into it. And I'll share my screen, and we'll sort of like you know build some stuff and just mess around with it. So yeah, thank you all for watching. And then the other thing is I've got my phone open here, and I'm looking at the live chat for the stream, and I'm gonna answer questions as they come in. So if you have a question, just post it there, and I'll just check here, and I'll pull it up on the big screen here and present it, and then I'll answer it, and I'll just do that as we go because there's only a few people watching live, and if you're watching live, I think you get some input into what we talk about here. Um, okay, yeah. So a quick update on Uqbar. We've been working for the past year really on a Urbit native blockchain. The form that we've decided to take for that is like an Ethereum rollup, but it has many of the properties of just a standard blockchain. The main thing that you really need to know is that it's a place to share globally attested, available data, um, and state for your programs. So there's a lot of places where that's important. Obviously, financial interactions of a decentralized nature require that, but so much more as well. So you can imagine, if you're any app you're trying to build where users may interact in um, a trustless way with regards to like finding consensus on some piece of data. So that could be the state of a multiplayer game. That could be the correctness of message history. That could be the set of users active at some period of time doing things, stuff like that. So yeah, we've built an execution environment. So that's a smart contract system. You can write contracts, deploy them to the Uqbar rollup, execute on them. We've built a wallet to streamline those interactions. We've built obviously sequencing apps to build those interactions and post them to chain. And we've built indexing tooling to share that data in a decentralized way. If you're familiar with blockchains today, you're probably familiar. Or if you're familiar with programming on blockchains today, you're probably familiar with providers that index chain data and serve it to you over an API, and that is a bottleneck for decentralization because if you're building like a DApp on Ethereum, let's say, you're probably going to use either Infura or Alchemy to gather chain state to present to your users in that app. And of course, chain state is what we're trying to replicate in a decentralized way. Oh, phone buzzing coming through pretty loudly. Okay, I'll just move the phone off of my computer here. Okay. Okay, so that should be better. So thank you for that. So our decentralized indexing system allows you to actually get that data directly to users without relying on services like that. And that's, of course, possible due to Urbit, right? Urbit fixes this. Urbit lets you share data across a peer-to-peer network. And there are a couple upcoming developments in Urbit Core that are going to enable this to like be truly performant. So I've been very excited about like remote scry and sticky scry. The main reason for that is because I want to get this blockchain data out, right? So the way a chain works is you have like a sequencer block producer that creates a new block, and the data inside that block, so the chain state and the transactions that were processed, need to then be shared with users, right? So you need to get transaction confirmation. You need to see the updated chain state. Your wallet needs to read how many tokens you have, stuff like that, right? And so, normally you have to rely on one of these professional indexers, but with our, Urbit network that we like so much, the idea is that the block producer, the sequencer, shares that data out to a set of many indexers, which are just ships, right, running on the network. The sequencer is just a ship. The indexers are just a ship. The sequencer publishes that new block data at a scry path. Indexers read that data, and then potentially other indexers or users or anybody goes and reads that data from them. So you have a web of data distribution that's like super, super decentralized. So yeah, remote scry enables that with sticky scry that is like subscriptions for remote scry, so that you can actually read data at a steady clip as it comes out, as it gets produced. So yeah, that's super exciting. Let's see. That's kind of an overview of where we're at. We have a testnet active on the Star Backdune. If you download our software from distr.zod Backdune, I'll put that in the chat here. You'll be able to play around if you haven't already. We've got a couple apps that have integrated already with the abilities that this provides. Of course, you've got like Pongo, which lets you send tokens as a chat message. That's sort of a canonical example. We've got an AMM app that lets you do token swaps. We've obviously got a wallet app built into that core app there. And then we've got an app called Orgs that lets you interact with a DAO contract that I wrote. And then there's some other apps trickling out. We've got a multi-sig management app. There was a version of Radio that had, smart contract integration. But I want to basically get into it now and start showing you how that works in practice. So can I get my screen shared up here? And then we'll just start getting into it. Okay, excellent. I see the screen has been shared now. Okay, great. So right now I'm looking at the SIR file for the wallet app. This is a good place to start because we're going to be producing transactions, right, that get sent to the wallet. But let me just get my dev environment set up a little more right here. So I've got a ship right here. We've got NEC. NEC is running as a sequencer, but I'll start from scratch so that you guys can follow along at home. So I'll make a new ship. Actually, I'll just boot this ship and I'll just nuke it. Yeah, I'll nuke the Zig desk so it's fresh. So if you know how to clone a repo and get the desk into your ship, you can get to this point where you're now running the Zig desk for the first time. So this is the Uqbar core repo in Uqbar DAO. So we're set up right here. And see if the sequencer is running. Let me just make sure it's not running. Okay, so we got all our apps running. It's weird the sequencer isn't running. Rain sequencer, rain zig, and sequencer. There we go. Okay, so now we're initializing the sequencer. So we'll let's just go write a contract. So the easiest place to start with writing a contract. Oh, I'm going to increase the font size in response to a message. So I think the easiest place to start with writing a contract is just in this repo itself. So I'll open like trivial.hoon, which is like the most simple possible compiling contract here. And then I'll copy this and then I'll make a new file. So this is now like, new contract. So we'll save this in the con folder, which is where we save our contracts sort of canonically. And then we're going to deploy this contract after doing some stuff with it, and then we'll run some transactions through it. So that'll be fun. The other thing I can pull up here is my localhost ship, because I want to get neck, and apologies for like the infinite screen, but I just want to get there we go. Yeah, so I want to get this up here. I want to use the wallet UI because that makes it nice and easy. So this is neck, and then you can see we've got Uqbar core installed, and we've got this screen. So I'll initialize the wallet from the README in this repo, so you can scroll through the README, and this is obviously shows you how to get set up to where we're at now, and it gives you the way to first of all turn on the testnet locally, and then import a wallet that has some tokens sort of like spawned in for you, so that you don't have to worry about that stuff. So just copy paste those lines in, and this will initialize the sequencer, right? And it'll set up our wallet. So now we'll have some tokens. So one other step that you have to do to get the tokens to show up is run a batch. So we do hepzig zap batch. Okay, we performed a batch. Now tokens should be showing up right now. So let's see here. Yeah, see, we've got our chain state here. Yeah, so we can see that the chain was initialized properly. And what if we just wallet-less debug here? Yeah, okay, so we have our tokens. I think for some reason this refresh just isn't happy with us. So yeah, there we go. Yeah, so sometimes the front ends can be a little unstable here. I think this is a development build. Yeah, so now we have tokens available. Yeah, let's start writing that contract. So there's a bunch of example contracts in this repository that are worth looking at, but let's just write something really simple here. So let's turn this write gate into one of these, so that we can put some stuff down here, so that we don't have to use a library file. So instead of using a library file to define our action, we'll just define action down here. So this is sort of similar to a Gall app when you get an on poke, right? So this is a transaction coming in, and you want to define the call data, what the transaction should look like. So this is usually, a buck-send, just like how a poke action type is usually like a buck-send of multiple options. So, we can do stuff here, right? We can do other kinds of stuff. So I would love suggestions from the chat for a simple contract to write, but I can come up with one if I don't get one in a minute here. I'm thinking super simple here. Let's just write a contract that keeps like a counter or a set. Yeah, let's do like, there's a DAO contract in this repo, but let's do like a super simple thing with no like validation that just keeps a set of ships and lets you add and remove from that set, because that'll demonstrate some important stuff. So yeah, so we'll just have two actions, add and delete ship. And then we're going to create our data type here that will hold as an item on chain. So one important note about smart contracts on Uqbar is that they're stateless. So we just have code. Code is stored in the smart contract, and there's no sort of mutability there. It's just code, and it produces side effects that are items that get stored on chain. So we can look at some of the type definitions here to make that super clear, but let's just call it for now like our state. And our state can just be super simple. It can just be a set of ship. Now, there's a problem with this, and I can explain exactly what's going on here, but the important thing to note is that we use a special hashing function in the Uqbar execution environment to make our data sort of introspectable when it rolls up to ETH. So for that, we're going to use a different hashing function in things like maps and sets. And instead of using a normal set, we're going to use a P set, which stands for Peterson set, so Peterson hash, but also potentially Poseidon set, because Poseidon hash is another valid hash that we might end up using here. So we use P sets in smart contracts instead of normal sets. Now, if you really want to dig in, you can look at smart.hoon, which is our smart contract standard library. Smart.hoon builds on top of a stripped down version of hoon.hoon. So you have access to all of your favorite smart or standard library functions here. Now you'll note like we're running a little out of date. We haven't gotten the latest Kelvin version for our Hoon yet. So soon we're going to have updatable contract libraries that'll let us get down to 139, 138, so on here. And we'll have versioning for this file as well. But you can see here, if we look at pset, that we have a whole pset thing. We have make pset that's like a silt function, but then we have a pset definition in pn instead of in. So normal set operations use the in core, and we use the pn core to do this pset. So yeah, it's just a bit of trivia. All you need to know is pset, pn, right? So let's write our action arms here. I say arms, but it's really like options based on the call data. So let's look at what the right arm returns. We return a quip call diff. Now, if you've written Gall apps, which I would definitely suggest learning how to do before getting into this, this will look familiar because it's very similar to quip card state or quip card this, right? But instead of cards, we produce calls. Calls are continuation calls out to other smart contracts, and diffs are the set of side effects in our data that we produce. So we have this is like sort of an empty result. So this can be expanded out. I'll make this really explicit. So our list of calls is just an empty list, and we return calls and then an empty diff, which is 4 sigs. And I'll go to the definition here to clarify exactly what this is. This is important to know. Yeah, so a diff is a set of changed items, issued items, burned items, and contract events. So your contract can emit events just like an ETH contract, and then it can do 3 things to items. It can issue them, change them, and burn them. You can only do this to items that your contract creates. So you have provenance over the items that your contract creates, and you're able to manipulate them here. So what we will do is issue some items. And if we have an item, then we'll change it. We don't need to worry about burn so much right now. And there is this pleasant helper function called result here that lets you just present these items as a list, and it builds out like the proper diff type for you. So let's use result here. And I'm just using that outer tick to indicate an empty list in a cell here. So yeah, we'll do an empty result. Now, we need another action here because we're going to be adding and removing ships from a set, but we need to initialize this contract. So recall that we can't store any data inside the contract, and so we need to somehow initialize this. So I'm going to create an onInit action. And this isn't going to have anything in it, but it's just going to build our item and put this in an item and issue it. So we can start really simple here and say, basically do a what hap, branch off the head of the action. So this will be onInit, add ship, or del ship, and we'll just produce results for those three things. Okay, so this is a valid contract. It doesn't do anything yet, but let's go ahead and compile it, and that can sort of build towards our next steps here. So I've got this desk synced up to this ship, so I'm just going to commit zig. We should see one file come in, and there's two steps here. You can skip straight to the contract compile step, but I find it helpful to first build the file. Oh, and let me bump up the font size a little bit here, just to make it easier to see on the stream. Yeah, that's good. So, so I'll use the build file thread to just take a first stab at building this because it's super fast. So we'll just build con demo hoon. Okay, so it built successfully. Now we can go ahead and compile it. So this step takes a little bit longer, which is why I like to take that initial step in case I have compiler errors. But now we zig compile, and this only takes a few seconds, but you can see here. So unjetted compilation, building the smart standard library, slapping this code against it, just doing some work here. So this is our output. This is knock. This is knock that has been separated from its subject. So this is basically pure formula. This is the contract formula. It's pretty big, but if you know knock, you can start to see a structure here. You know, we have a battery and a payload. The payload holds contract libraries that you import. Not important to just get started. The important thing is that we're going to save this knock as a jammed noun, and that's actually the compiled contract that we're going to import and play around with. Well, we actually don't need to do that step, but I'll show it to you anyway. So I'll just do .demo/hoon or .demo/jam, and then hit compile. So compile the contract to a jammed noun, and this gets saved inside of our Urbit ship, and I'll show you where as soon as it completes. And then we're actually going to deploy this contract as is on chain, on our fake local chain, and that'll be useful. And then we'll add some utility to it. We'll make it actually do stuff, and then we'll deploy it again. So if I close out of my ship here and I go into the ship /.urb/put, you can see now all of the contract compiled jams that I've built. So I can copy this back in to my con compiled folder. So I have con compiled, and you can see a bunch of jammed nouns here. So these are compiled contracts. If you try to open them, they look like this, you know, in my editor anyway. It's a jammed noun. So that's cool, but we actually don't need to do that right now because I'm going to go back and turn the ship back on. And I'm going to deploy this actually. So there's a contract pre-deployed on chain called publish.hoon. And what publish.hoon does is it deploys new contracts. I'm sorry, that's the jammed version. So you don't need to read this, but this is a contract that's already deployed at a fixed address, and it lets you put other contracts on chain. Now you can write your own publish contract, which is a cool thing. And you can do other custom behaviors. But the important thing for us is that we have deploy and init as a possible action here. So I'm going to show you how to deploy this contract. So first of all, we've got a wallet here. And this wallet has some tokens in it, so we can pay for gas. It also has a pub key address, and you can even see the private keys here because it's a hot wallet inside the Urbit ship, which I would never recommend using in any real setting. But for testing, it's great, which is why we have it. So we're going to build a transaction in the dojo right here. So the first thing I'm going to do is get that code block. So I'm going to say tis code. And I'm just going to put the result of this compilation step at that variable. So that'll give us that knock we saw in the dojo earlier, because we're actually going to deploy that in a transaction. That's how we post new contracts to chain. And I'll pull up the type here that we're going to use. So we're going to build one of these deploy and init transactions. So I'll go to publish.hoon. I'll go to the library where you have the definition. So this is what our call data is going to look like: deploy and init. So we'll make it mutable because we'll put out an upgrade later. That'll be fun, because right now our contract doesn't do anything. So we'll put out an upgrade later. But of course, in production, you generally want to deploy immutable contracts. Okay, so we have our code, and then let's make our call data. So this is going to be deploy and init. Mutable is yes, send.y. Code is that code variable we just made. Interface, we can leave this empty for now, but this is a place that you can put a typed path. That's what a pith is. And then that lets you sort of like build out basically a mark file for your contract types, but we don't really have to get into that right now. And then we'll put our init call data. So leave that empty, and then our init call data looks like an action inside of our just deployed contract. So if you look at the code for publish.hoon, what this is doing is it's deploying your contract and then immediately calling it with this call data. And what's cool about that is we can run like an onInit step only once ever. So we could put something here like, assert equals id.caller.context, the publish contract address, which is this hard-coded value. So we could do something like this if we wanted to make it so only the publish.hoon contract could ever call this step. But as I'll explain later, for some cases that's not even necessary. But we'll put our call data here anyway. So we'll say on init sig. So that's our valid call data that we put down here, and we could put anything here, but we'll do that one. So that's our call data, and then finally let's build the transaction. So we're going to poke the wallet with a transaction, and I'll show you where to find this type. So you can do this at home. So in the wallet.hoon ser file, serzig wallet hoon, we can build a transaction poke, and this will have an origin, a from address, a contract ID, a town, and an action, which we can then also see down here. So I'll just build it out. So for origin, we can keep that empty right now. For from address, we're going to use our pub key address, which is why I printed out this debug. So you could get this from wallet debug, or you could get it from your front end here. Let's use it there. So we have our from address. We have our contract address, which is that 0x1111.1111 value. Just for reference, I'll go back to the block explorer, and I'll show you that file. So here we go. We have the published contract right there. Right now, you don't get a lot of information from the block explorer. You can print it in your dojo if you look through the indexer code, but very soon, hopefully, we're going to have more information available here so you can interact with contracts. That's what that interface value is for, coming soon. But yeah, okay, so let's deploy to that. We've got the from contract. So town is 0x0. That's the one town that we have active right now. We will soon have multi-town, which is like a sharding thing, but you can just keep this to be 0 for now. And then we've got our call data. So let's just try this poke and get that pending transaction. Oh, I messed something up here. Oh, right. So I can't just put the call data here. I have to do one of these supported actions. So supported actions are, we have like sort of like built-in helpers for the token contracts. And then we have text for parsing like text from the front end. And then we have noun. And noun is what we want to use here because we just have a noun. So our noun is that call data noun we made. And now we can, okay, so great. So that went through to the wallet. Now we've got a pending transaction with this hash, and we can approve this from Dojo, but just to show you the front end functional, I'll go back to the wallet and I'll go ahead and sign this transaction from the front end. So we've got a pending transaction here. We're going to sign it. We can look at the call data. It's really crazy because we have a whole contract in there. We can set a gas price and we can submit. So we just send the transaction and we can go back to our Dojo. And it's taking a fair second here, but usually this is instantaneous. Must have something to do with a newly booted ship. But anyway, we got a completed transaction, and you can actually already see in our wallet front end that we have a contract. So this is a contract that we hold, and we can upgrade deployed by that published contract. So great, our contract is on chain, and we even have the contract ID available for us right here. So that's cool. We can copy that, and we're going to put that in our Dojo right there, because we're going to use that to produce transactions that call this contract. So the first thing I'll do before we go back and fill out our contract is do a simple call. So I'll do a very similar thing to what I did up here, but instead of calling the publish.hoon contract, I'm going to call our contract. So our contract, town is still 0, and then the call data here is going to be a noun again, but this time we're going to use one of the call datas that we produced here in our action step. So let's do add ship. This is not going to do anything right now, but we'll upgrade the contract to make it do something in a minute. So add ship, and then we'll just add ourselves. So we're neck. I'll just do that. Okay, great. So we have another transaction pending. Instead of going back to the front end again and again, I'm gonna just do this from the Dojo now. Now I'm going to use this submit poke, which is just signing a pending transaction. So we use our from address. This is our wallet address. And then the hash that we just got, which is pending here. So we just copy paste that in. And then we do our gas values. And one is the gas rate, so that's a multiplier of the cost of the gas, and then 1 million is the actual number of gas units. So if you're familiar with Ethereum, it's a very similar system, and 1 million is always going to be more than enough. Where these transactions are costing in like the low thousands of gas. But anyway, so I'll approve that transaction. Okay, great, it went through. So that transaction was successful, and we can look at the block explorer actually. Go ahead and reload the page. I can look at the block explorer, and you see that there are no transactions coming. That's because we need to run a batch. So we'll do that zig zap batch, and our transactions will be put into a batch and then displayed in the block explorer. So bam, there we go. We have 2 successfully performed transactions. So our latest one had this bam add ship. So that's really cool. That's really cool. So there we go. Yeah. So now we've got a contract deployed. We're building transactions and we're sending them through. Now what's really cool is you can get straight into building apps now, just with this information, because what we're doing in here in the Dojo is we're producing pokes to the wallet, right? And then those pokes become pending, and then you go over to your wallet and you submit them. You can do this from another Gall app. So as an example, I'll show you this orgs app that I built for managing my DAO contract. So I put the contract ID in the SIR file, I put the town ID in the SIR file, and then I just go ahead and build out these orgs actions, which match the action type in the orgs contract. And then I just build inside the orgs app I just build transactions, right? So we can look at the onPoke stuff here. So we go up to onPoke. We get an orgs action from the front end of this app. We handle that action, and we produce a poke to the wallet. So we go in and just sort of do some preparatory stuff, and then we build out one of these wallet pokes to our .bol wallet that has all that transaction information. So like that's basically all you need to know to just get the bare minimum going, right? But the next thing I'm going to show you is how to. I mean, do we have any questions before I keep going here? I think we're gonna wrap up. I guess definitely by 4, definitely by the end of the hour, but maybe at 3:45. I'm not quite sure. But all right. Well, I don't see any questions, so I'll keep going. Yeah. So the other thing you need to know to handle transactions, other than poking the wallet, is getting a receipt from the wallet. So this is what gives you the result of your transaction. So that's what the origin field is for. If you go back to the wallet definition and you look at this origin field inside the transaction poke, what this is a destination for the wallet to poke you back on to get the receipt from the sequencer. So we can fill this out, and we'll get poked with the outcome. So if you look at the origin definition up here, it's just a unit. That's why we could keep it empty, but a pair of term and wire. So the term is the app that you want to be poked at, and the wire is the wire you want to be poked on. This is not secure. We're waiting for Urbit Core to include like app provenance to make this like secure and trustworthy, so that you can only sort of set yourself as the origin. So for that to happen, of course, the wallet needs to know what app it's being poked by, but that's coming very soon. So anyway, soon you won't even have to fill this out, right? Soon this will be automatic, but you can put an origin for now. And what that gets you is a sequencer receipt. So this is what you get poked back with. This gives you the transaction hash, and then it gives you this sequencer receipt data type, which is stored in uqbar.hoon in the ser folder. The sequencer receipt is a signature from the sequencer, both their ship and their Uqbar wallet address. It's the position of your transaction in the transaction set for that batch. It's the actual transaction that you sent, and then it's the chain output. And that output includes those changed, modified, burned items and the events. So that's all the information you need to know in your app to operate on this data. So integrating with this is super simple. I'm really excited to once we lock down some of the subscription reform stuff in Urbit Core, once we lock down some of the app provenance and permissioning stuff, we are going to be able to just, explode with integrations using this stuff. That's my hope anyway. So if anybody's interested in doing something like that, DM me on Urbit. I'm very happy to help with wallet integrations. I'm definitely of the opinion that without integrations and composability, what's even the point of building on Urbit, right? This is really the special thing that we're gunning for here. So we really want to be we really want to have apps build these integrations. And it's going to be really symbiotic, because it gives everybody a lot more leverage if we can do these integrations. Now, there are some things that are important for app integrations. I've been thinking about what's missing from Urbit right now to enable them, and what's missing from apps. And I'm probably going to be publishing a little piece on that soon, because I think there's a few steps that people can take to make their apps more integratable with. And I think when we can get there, it's going to be really exciting. Okay, so let's get back to that contract. Let's get back to demo.hoon here and add some behaviors. So this is just, standard hoon, but I'm going to show you how to build items and store state on chain because that's important. So the first thing we want to do is in the onInit step, in that action, we want to build out our state item that holds this set. So I'm just going to make an item here. And this type definition, again, is in smart.hoon. So I'll just break this out onto the side here so we can look at it as we build. So I'll show you exactly what's going on. So we have an item here, and we're going to build a data item. So this item is going to be a send Pam to show that it's the first option in this each statement. And then we're going to have an ID for the item. And I'll fill that in a minute. And then we're going to have a source, holder, town, salt, label, noun. That's a fun to say that fast. So source, this.context. This has to be the case. This.context is just the contract ID. Holder will also make this.context for simplicity's sake. Town is town.context. Simple enough, right? Salt we can keep 0. Salt is really important if you have a lot of pieces of data coming out of a contract because you need these values to be uniquely identifiable. And I'll show you why when we make the ID. But this can be 0 because we'll only ever have one item. The label can be our ship set. This can be whatever you want. Obviously, it's semantically meaningful. And then the noun itself is this data type right here. That's what we want to set up. So we're just going to do, I'm actually going to call this our ship set just to be really unambiguous here. So I'll just make our data type here the bunted version of this, our ship set, which is, of course, just going to be an empty set. Okay, so that's an item. Let's build that ID. ID here. So the ID hashing functions are included in the standard library. We're going to use hash data. So hash data. And then you can see the inputs here are very similar to the inputs here. It's just going to be, again, source, holder, town ID, salt. So we'll just do that. Do this, town 0 of context. That's just a shorthand way to fill out this. Super helpful. So that's our ID, and that gets put right there. And then our result is, remember, changed, issued, burned events. We're going to edit this issued list to be a list of one item, just the one we just made. Bam. Simple as that. So this will put that item out onto chain state. That's ready to go. That's basically finished. Now we can talk about add ship and del ship. So in both of these contract actions, we are going to want to first scry for this item because we know it exists, and then modify it, and then put it in our changed list here. So for both of these, I'm going to start by doing, and I'm writing like, the super, I'm trying to like keep this super verbose, right? You could obviously compress this down. You can do whatever you want with your runes, but I'll just keep it super verbose. So I'll do item. So I'm going to do scry state, which is another function in the standard library right here, scry state. So we do scry state and then item ID. So the ID here, we can pass in our call data, or we can just generate it here because we know it. Now this is like gas expensive, but again, we're writing sort of a sample contract here. So I will just generate this ID before we even get into the action step. So I'll just always generate that right up here. So now we can just do scry state ID. Now this returns a unit, and we know that exists. So I'm just going to wrap this in a need, just like that. So in both add and del ship, we're going to scry for an item. We need the item. And then we're going to modify the item. But in order to modify the item, we first need to unwrap it. So this is a function called husk. And what husk does is it takes this untyped noun stored in our item on chain, And items have to be stored as untyped nouns because we don't have the ability to store the subject for a noun. And therefore it's mold and all of that, stuff on chain, because chain space is a limited asset, and you need to optimize for that. So we have to first mold our item to make it useful. So what I'm going to do here is I'm going to modify this slightly. So I'm just going to call this, I'm just going to get that, right? Put it in the subject. And then I'm going to actually call item as husk. I'm going to husk. I'm going to provide a mold that's going to mold this noun. So the husk here is our ship set. I'm going to provide the item itself. So that's just the thing up here in the subject. Right? That's what the HEP stands for. And then I have an optional source and holder, which lets me forcibly verify that the item has this source and this holder. But since it's always the same item for us, we don't need to do that. So we can just keep those empty. So that's how I'm going to get this item. Then all I need to do here is put the ship in the set and then return the result. So I'm going to just do is dot. I'll do a tis dot on the noun dot p dot item. Actually, I don't have p dot here. So yeah, it's noun dot item. So okay, tis dot on noun dot item, and then we'll just do a little put pn, not in, because it's a p set. And then we'll use the ship dot action from our action here. Modification step, and then all we have to do is return the result. So in our changed list, we will do. Now I need to put that header back on this item. So I just need to do that send pam again to make it match the type definition, and then just pop it in the list. So this is the full function. I can actually just copy this whole entire thing down here and replace put with del. And this should compile. Let's test it. So I will commit zig. I will do the build step. It built. Let's go ahead and assign the compiled version to code again. And then I realized that instead of upgrading the contract that we already put on chain, we should deploy it again, because we added something to that on init step, and we won't be able to call that if we upgrade the contract. So let's deploy this as a new contract. So we've got the code. And then let's do the wallet poke again. That performs the deploy. Oh, let's build our call data. So we have deploy and init. This time we'll do non-mutable, right? We'll deploy a non-upgradable contract because we're so confident. We audited our code. We're ready to deploy, right? Okay, so we've got our code, and we still want to do this on init step. So yeah, let's make that the call data, and then let's go back and deploy this. We don't have to change anything here. And this contract will automatically be deployed at a unique address based on the hash of the contract code and your wallet address and other things. So you can pre-calculate this if you need to for your app. Okay, so we have the pending hash here, copy in that hash, and then I'm just going to, again, submit from Dojo again. So I'll do the submit step, and I'll change the hash here. I'll keep the same gas. And I see we're like running out of time here. I'm sorry we didn't get to do more, but I'd love to answer some questions if anybody has any. Okay, so we just deployed our contract. I'll go back to the front end and look at the wallet. Okay, again, I think we might be getting some bad front end data here. So I'm going to go ahead and run a batch. Yeah, we're doing this. We're running on a sort of a pre-release build of the wallet front end, so I think there might be an issue. But there we go. We've got our deployment. here. And so we can actually, this is a good example of looking at a transaction and being able to see useful information. So we can look at the output of this transaction and see that, yeah, it did go through. And in fact, we can see, okay, our account was modified. We paid for gas. This data item was modified, as in we created our ship set. You see that label right there. And then we also modified and produced a contract. So we have the contract ID, and that's right here. We can just use that. So copy that, set that in our dojo. And of course, you can put this in an app. You can do whatever you want with this. And let's now try to modify our ship set. So we've got this data item on chain. So I've got this, right here. So there we go. So we actually have the raw noun visible right here. And again, this is one of those things where the contract mark file or the interface file is going to make this like a rich, a thing, a piece of JSON that you can manipulate. But right now we've just got an empty set. Let's see if we can add a ship to the empty set and make this change. So I've got my contract ID. I'm going to produce a new transaction. And that transaction is going to look like add ship. Our contract ID has been changed. And we're going to do a noun, and we're going to do add ship, and yeah, let's add neck. So transaction pending, submit step. And by the way, you can automate the submit step in testing by approving an origin and then setting an origin in your transaction poke. So that's a bit of knowledge for you. So we just ran the transaction. Let's do zig batch to build a block. Okay, so we should refresh this and see some new information. Bam, there we go. That's awesome. So this is our new ship set. 100. What is this 100? Well, let's take it back to our dojo and do a little mic action here. Set ship 100. There we go. That's our ship set. Perfect. So now we have a contract that we can manipulate. We can add, we can add another ship. We can add bus. We can delete a ship. So I'll go ahead and add bus and delete neck, and then I'll probably call it a day. There we go. We just added bus, and then before even calling another batch, we can make another transaction to delete ship, because they'll happen, one after another. Delete ship neck. Submit that transaction. And then I'm going to call zig batch to put those transactions into a new batch and show up in the block explorer. And so we should see this number replaced with the atom that represents bus. And there we go. Awesome. Well, thanks, guys. I would love to see, some people trying this out and writing contracts. So thanks for listening. If you're listening to the recording, thanks for listening to that. I'm all done here, Sam. So if you want to turn my screen share off, yeah, we can wrap up.